In this video, we'll review synthetic division of polynomials. Let's review the division algorithm. Given any function f of x that's a polynomial function, if we divide it by some other polynomial, d of x, which we'll call the divisor, it yields the quotient plus any remainder divided by the divisor. This can be rewritten as the product of the divisor times the quotient plus the remainder. So when we do synthetic division, we're going to say whatever our divisor is times the quotient and then plus any remainder that we have left over. Synthetic division is a shortcut for long division of polynomials. It's a quicker way to do it. However, synthetic division does not always work. Synthetic division only works when you have a linear divisor. That means something in the form x minus a. So this only works for linear divisors or linear polynomials. So it would work for things like these, x plus 2, or 3x plus 5, or 4x minus 11. But it won't work if you have something of a higher degree. If we have, for instance, like x squared plus 1, or x squared plus 2x minus 4, or even something like x cubed plus 8x squared, this no longer works. If it's anything higher than first degree, meaning just an x, then it's not going to work and you have to go back to using long division. So synthetic division is nice, but it's limited. It only works when you have the linear factors. So let's look at a few examples. To use synthetic division, we're going to determine if x plus 2 is really a factor of f of x equals x to the fourth minus 5x squared minus 10x minus 12. And the way we're going to do this is we'll complete the synthetic division. Just like long division, we'll look to see what the remainder is. If the remainder is 0, then we know it's a factor. If the remainder is not 0, then it cannot be a factor of the polynomial. When you do this, just like long division, you need to remember to put in any zeros for missing terms. I've got to make sure that things are lined up. And it's a little bit more important on synthetic division. We'll see why here in a sec. Now, to begin synthetic division, we're going to list the coefficients of the polynomial function. This is a 1x to the fourth, so the first piece is a 1. I don't have an x to the third term, so we'll put a 0 there. I see that we have a negative 5x squared, so the next piece would be negative 5. We then have a negative 10x, and then lastly our constant is negative 12. You have to be sure on this that if you have a missing term, meaning we went from an x to the fourth to an x squared, you've got to put a 0 for it. Otherwise it won't work. Now the factor is x plus 2. Because the factor is x plus 2, the root is negative 2. To begin, we bring down the first term of our coefficients. We'll now multiply the negative 2 times the 1. Negative 2 times 1 is negative 2, and we write that underneath the next term. We now combine the 0 and the negative 2, and 0 plus negative 2 is negative 2. We multiply the root times this new term. Negative 2 times negative 2 is 4, and that goes underneath the next term. Combine like terms, negative 5 plus 4 is negative 1, and then multiply again. Negative 2 times negative 1 is 2. Move that, and then add. Negative 10 plus 2 is negative 8, and then multiply one more time. Negative 2 times negative 8 is positive 16. Move it over, and lastly add. Negative 12 plus 16 is 4. So this one has a remainder of 4. If it has a remainder, then you know that negative 2 is not a root, which means that x plus 2 is not a factor. Because this one has the remainder, we know that we do not have a, we know that this is not a factor. So again, because we have the remainder, we know that x plus 2 is not a factor. And the polynomial would be written, or the function would be written as the quantity x plus 2 times the quantity x cubed minus 2x squared minus x minus 8 plus a remainder of 4. Now let's take a look at another example of synthetic division. Here we're going to use synthetic division to determine if negative 3 is a root of the function. To do this, we're going to take and divide it out, and we'll look at the remainder. If the remainder is 0, then we know we have a root. To begin, we're going to list the coefficients, and we got to make sure that if we have any gaps, we put a 0. However, this goes x cubed, x squared, x constant, so there's no missing terms. So the coefficients would be the 2, the 5, the -7, and the -12. The root is -3, so we'll bring that down as well. Bring down the 2, and let's begin our synthetic division. -3 times 2 is -6. Move that over and add. 5 minus 6 is -1. Multiply again. -3 times -1 is 3. Add. -7 plus 3 is -4. Multiply again. -3 times -4 is +12. And add one last time. 12 minus 12 is 0, so we get a remainder of 0. If we get a remainder of 0, using the remainder theorem, we know that this was a factor. So if -3 is a root, then yes, this is a factor, which means the factored form would be the quantity x plus 3 times our new piece, our quotient would be, this is now a 2x squared minus a 1x minus a 4. We took out a factor of x, which means all of these are going to drop down one exponent. Now I also need to look and see if I can rewrite this. The 2x squared minus x minus 4 might be factorable. So I'm going to take and multiply the first and last terms. 2 times -4 is -8. And I'm going to think, are there any numbers that multiply to be -8, but add to be -1? Now there aren't, which means this is factored. I cannot factor this any further, so this problem's done. The factored form would be f of x equals the quantity, x plus 3 times 2x squared minus x minus 4. And we're done with this one. Now let's take a look at one more example. We're going to use the synthetic division to find all the roots or the zeros of this polynomial function. To set it up, we're going to go ahead and we're going to list our coefficients. This function goes x cubed, x squared, x constant, so there's no missing terms. So the coefficients are 1, 8, -9, and -72. The factor is x plus 8, so what would the root be? Hopefully you said -8, and that's what I'm going to write down here. Now at this point, I'd like for you to pause the video, work this out, and then check your answer. Resume the video when you're ready. I'll give you a second to get ready for this. Hopefully you've had a chance to work this problem out. To begin, we're going to bring down that 1. -8 times 1 is -8, and now we'll combine. 8 minus 8 is 0. -8 times 0 is 0. Move it over, and -9 plus 0 is still -9. -8 times -9 is +72. Move it over, and combine. -72 plus 72 is 0, which means yes, it was a factor. -8 is the root. So the new form of the polynomial function would be the quantity x plus 8 times the factor was just an x, which means all the exponents go down just 1. So this is going to be the 1x squared, no x's, and -9. Now x squared minus 9 can still be factored. That's a difference of squares. I know that x squared minus 9 can be rewritten as the quantity x plus 3 times quantity x minus 3, and we still have that quantity x plus 8. Now this would be the factored form of the polynomial function. However, the directions were to find the roots, or the zeros, which means now I need to solve it. Using zero product property, I can set the equations equal to 0, which means that x plus 8 is 0, x plus 3 is 0, or x minus 3 is 0, and the roots are -8, -3, and +3. I hope this helps you understand how to do synthetic division, and thank you for watching the video.